Welcome to the course of Internet Protocol version 6. So in this course we will discuss about the various aspects of the IPv6, and here we will start our course with very basic terms and goes over to the advanced level. So in today's class we are going to discuss about the brief introduction to IPv4. So before IPv6 we are on the IPv4 addresses. So before discussing about the IPv6 we have to discuss brief terms of the IPv4 addresses. So let's start with here we will discuss about its address type, notation, IPv4 packet format and the NAT process. So starting with the first, what is the IPv4 address? So here IPv4 stands for the Internet Protocol version 4. So it is the fourth version of the IP addresses, and before IPv6 we are using these IPv4 addresses to give the identification to a device in a network. So it is a connectionless protocol that is used in a packet switch network such as the internet. And here the IPv4 is designed and specified in IETF, that is Internet Engineering Task Force publication, that is RFC 791. So it provides the logical connection between the network devices by providing authentication to each device. So these IP addresses act as the identification to a devices in a network. Next is address type. So here the address space is the total number of addresses used by the protocol. So here the IPv4 is a 32-bit address, which means it consists of 2 raised to power 32 address space. And the example here I have given of IPv4 address, it is written as 117.149.29.2. So this is the decimal notation of the IPv4 address. So here this 2 raised to power 32 address space means there are total of 4 billion devices that can be connected to internet by using the IPv4 address. But due to some imposed restriction, like we have classified these IPv4 addresses into different classes like class A, class B, class C, class G and class E. So as they are classified, so we have imposed some of the restriction to these IP addresses. So the actual number that are available in IPv4 address space are much less than 4 billion. So next we will discuss about the notation. So here the IPv4 address can be represented into two ways. The first one is the binary notation and second one is the dotted decimal notation. So the binary notation, here we will use 32-bit address in which there are 4 octets each having the bytes. So here the 4 octets are like first, second, third and fourth. So these are separated by the dot. So this yellow color 0 and 1 bits represents the binary notation, and these total consist of 32 bits. And dotted decimal notation, here the each number in dotted decimal notation value ranges from 0 to 255. So here we have represented 172.16.150.12 in decimal notation. So here this decimal notation is converted into the binary. So this is the binary form of this particular address. So here dotted decimal notation, IPv4 address are written in decimal notation to make it more compact and easier to read. So most of the time we will use this decimal notation to represent the IPv4 addresses. Next is the header of the IPv4. So this is the packet format of IPv4 addresses. It consists of IP header and the payload data. So here the IP header will consist of the source address, destination address, the header length, the next header. So these are the information that are added in this IP header. But in this payload data, it will contain the original data of the users. So here the IP address is of 20 to 60 byte long, and here is this total IPv4 packet format is of 65,535 byte long. Next is the IPv4 header. So here IPv4 header have many fields in between. So it starts with the version, header length, TOS, total length, identifiers, flag, and then the fragment offset. And we have added the TTL, protocol header checksum, and it will contain the source address and destination address with option and padding. So this total header size is of 32 bit. Let's discuss about these one by one. The first one is the version. So here the version will indicate that the 4-bit field is set to binary 0100 for the IPv4, and if it contains the value like 0110, then it means this is a IPv6 packet. So here this first field of IPv4 packet will tell about the version of the packet format. Then part is the header length. So here header length is also known as the internet header length, and it is the second field of the IPv4 header, and it consists of 4-bit long. So it tells the number of 32-bit words in the header. It means it is telling the total length of the header part only, and the minimum value of this field is 5. Next part is the type of service. Type of service, that is TOS. So here it is also known as differentiated service code point, and it is of 5-bit long. And here it tells the real-time data streaming applications such as VoIP. It will use in this process. So here it carries the information about the quality of service of the IPv4 packet. So after that, the next part is the total length. Total length field is used to define the length of the entire IP packet. So as header length is only defining the length of the header part, but total length is defining the length of the complete IP packet. Next is explicit congestion notification. So here this ECN carries the information about the congestion seen in the route. So this is 1 bit long, and it allows end-to-end notification of network congestion without dropping. After that, the next part is the identifiers. So here identifiers, the identification field is used for uniquely identifying fragment of an original IP packet. So it used for adding packet tracing information to help trace datagram with spoofed source addresses. Next is the fragment offset. This fragment offset field is 13-bit long, and it will this offset tells the exact position of the fragment in the original IP packet. Next part is the protocol. So here it indicates the protocol that are used in the data portion of the IP packet, that it is consisting of ICMP protocol, TCP protocol, or UDP protocol. If it is ICMP, then the value for this protocol is 1, protocol field is 1, and if it is TCP, then the protocol field value is 6, and if it is UDP, then the protocol field value is 17. After that, the checksum, header checksum. Header checksum are basically used for the error checking of the header, and it is of 16-bit long. And source address indicate the IP address of the source of the packet or the generator of the packet, and whereas destination address is the receiver of the packet. It will include the address of the receiver who is going to receive the packet. Next is the flag. So here the flag, there are 3 bits field that are used to control and identify fragment. The first one is bit 0. If it is set to 0, it means it is reserved bit, and there is no fragmentation is done. After that, bit 1 indicate that there is no fragmentation, and it is indicated as DF. Bit 2, it will indicate that there is more fragments, and it is indicated as MF. Next part is time to live field, TTL field. It indicates the maximum time for which a packet is allowed to remain in an internet system. So here the intention is to cause undesirable packet to be discarded. So the maximum datagram lifetime is range from 0 to 255, and it is 8-bit long. The option field here, it is used for the it is reserved for the future use, so that's why this is an optional field in IPv4 packet format. So these are the various fields that are in between the IPv4 header part. The next is the NAT process. So here the NAT stands for network address translation or network address translator. So it is a virtualization of internet protocol addresses. The network address translation is a process where a network device like a firewall assign a public address to a computer inside a private network. So in NAT, there are the private addresses ranges used like class A, class B, and class C. So class A addresses are 10.0.0.0 to 10.255.255.255. Next, The class B addresses are 172.16.0.02, 172.31.255.255, and the last one class C that are mostly used, that is 192.168.0.02, 192.168.255.255. So this help in improving security and decrease the need of large number of IP addresses in an organization. So this is a very helpful process, that is network address translation process. So here how this technique will work. So here the NAT technique work well for computer that only have to access resource inside the network. So like we are designing a network, and in network we have a few number of computers or laptops. So we want to that these computers and laptops must share the information with each other. So we are designing one private network. So for example, host want to access file server or the printer. For that we also use this NAT process. Thus using private address router inside the private network can route traffic between the private address with no trouble. But if a host want to access the resource, like if that devices want to access the outside network like the internet, then host must have a public IP address. So here in this way NAT address translation work. So this diagram shows the description of network address translation. Like here I have designed a network with these three computers having an address of class A, that is 10.0.0.2, 10.0.03 and 10.0.0.4, and this is a NAT router having a two port. So to one interface we have given an address 10.0.0.1, and to another interface we have given 145.12.131.7. so these are the private IP address, whereas this is a public IP address. So here what we are doing here, if these computers want to communicate in between the network, they will route the packet by using their private IP addresses. But if they want to access anything from outside the network, they have to use their public IP address to be used for the external network. So if in case any of the device from the internet want to access or want to send message to these devices in the private IP address or private network, what happen, it will use this address and the message will receive by this, and after this it will send the message to these devices in the private network. So it means in public IP, in external network we are only known by this public IP address, whereas in the private network we are only known by this particular address. So this is a NAT process where we are using private IP addresses and public IP addresses to differentiate the internal and external network. So this is all about the brief introduction to IPv4 and with NAT process. Thank you.